everybody. Welcome to an advanced session of Power BI data modeling. We are CCG Analytics out of Tampa, Florida, and we provide data analytics solutions to customers in need to understand their customers better, to understand their business better, to control and govern their data better. You name it, we provide strategy, analytics, and data services. My name is Doug McClurg. I'm a solution architect, and I've been working in this industry for a little over 10 years now. And I've served in a number of industries in doing so, and I've learned an enormous amount. I've seen Power BI grow from basic Excel tool to enterprise powerhouse. So let's dive in. So this particular course is an all-day course, and there's no way we can get through all this content. So I want to focus instead on some of the best practices, things that we see in the field, so that we can help solve the most common problems. And I also want to go a little bit beyond the Power BI data model itself and try to dive into what Microsoft wants business analysts and business professionals in general to become more comfortable with moving and transforming data more than simply consuming it in reports. So the experience that you need to create data models and create analytical reporting for your company is expanding, and Microsoft wants you to expand your skill set, and so we're going to touch on some of those technologies today. So the all-day course has kind of a breakdown like this, and we'll get as far as we can here. Okay, so let's start at the basics, and then we'll kind of scale up to a demo, and we'll kind of circle back on some newer technology. So in general, I think if you're on this course, you've probably played with Power BI before, and you understand that a data model is the thing in Power BI with your tables and relationships between it. What's important though is that this Power BI does a lot of stuff for you. It'll create the relationships automatically depending on what data you throw into it. It'll do a lot for you, and you need to pay attention to what it's doing and understand what it's doing so that the three most important things are possible. One is that folks who use your data model understand the data better if it's modeled correctly. If the more complex it is, or the more convoluted it is, it either won't get used or people will ask you questions constantly. In addition, a good model performs really well. It's not too difficult. I mean, Power BI is a very powerful tool, and the in-memory engine is extremely powerful, but it is fairly easy to create models that, with just in a few months of processing it, will perform poorly. And so you got to understand kind of the principles so that every time you make a new change and you add to your model, you're kind of going in the right direction. And you make sure that the performance doesn't start to lag over time. And finally, in the same vein, a poor data model does not evolve well. And it's very difficult to go back and change a model once a lot of people are using your model. And so I'm not saying spend days or weeks agonizing over a change, but you do want to spend some time and not throw stuff out there into the Power BI service that will, in the end, make your life worse because it's harder to evolve that model. So take more time than you think to consider some of your model changes, and I think you'll have a happier life each week. So some of the things, to break this down a little bit further, you're in control of nearly everything about the experience that a person has with your analytics, how much insight they get out of it, whether it actually helps them in their day, that is, saves their time, does it perform well. And as we, after the break, we're going to talk about some more advanced technologies that as a business analyst, becomes more skilled with the Power Platform, and you move a little further upstream in the data process and help what was typically IT's job to move data around, you become more responsible for the data quality. And that's both a good and a scary thing. But it also helps the business get their insights faster. So it's important to know that the modeling concepts you have here do drive data quality, that you can quickly, if you make a model that's complex or one that has relationships going in the wrong directions, that it's very easy for folks to get wrong answers out of your data model. And as we'll see, in terms of performance, there are some infrastructure choices that you, as a, given the tools that Microsoft is now exposing to the business, that their choices actually have consequences in terms of infrastructure, where that used to be just an IT's job. So the principles that I typically follow in my head, and I try to, convey to my clients, is that the number one thing is data quality, right? If you try to overwork your model for performance early on, you risk running into data quality problems earlier than you expect. That is, sometimes performance enhancements in Power BI require a lot more DAX rather than less DAX. It requires more complicated relationships. It requires a little bit more transformation of the data ahead of time. And all of that means a more complicated model to maintain. And by its very nature, the chances of you messing up are high. And so if you try to do it simple, even if it doesn't perform super well, make sure the data quality is there first and get it in front of somebody and get another pair of eyes on it. And then start iterating over that and working on your performance second. And then what you see on the left and right are this UI and UX idea that, Microsoft is trying to build an enormous amount of AI around the Power BI product, including, and I think it started with the Q&A feature where I can just type in a sentence and I'll get a visual back. Because Power BI understands my model, that it can read my model like a human would. The problem is that, and we run into this all the time, is that people name their columns and their tables as if it was a database. And I'm not saying it's not a database, but when you name things like dim account or fact sales, or you, even worse, do a lot of acronyms and underscores, it makes it more difficult for Power BI to overlay any kind of AI on top of that. So you want to keep your names really simple, really straightforward. If you're going to have a sales table, just call it sales or call it invoices, or call it customer, not dim customer, things of that nature. That's a UI experience. That not only is a UI for Power BI itself to provide AI, but it's a UI for your users to not have to come ask you questions about exactly what does this mean or how is this different than some other thing. And then user experience, again, this goes back to your model being straightforward. And there's a difference between something being simple and something being straightforward. I can simplify a model to the point where it's actually a little bit more complicated to understand than before. And straightforward is, the typical, dad test. If I showed this to my dad, would he have any idea what he's looking at? I hope he would, at least at a high level. And that's kind of the straightforward test. In addition, you want to kind of use all the metadata features of Power BI. There's fields for you to put a definition in. So write a quick sentence in there about what the measure is, like what the typical definition is for that measure. And you don't want to write a paragraph in there, but and that'll show up in the tooltip when somebody's using your dashboard. And that's just all, again, about the user experience. That's going to drive adoption, which we have found to be the hardest thing about analytics at companies, is the adoption side. And so the more you can focus on UI and UX throughout your process, and then focus on data quality first, the deeper analytics is going to penetrate into your organization, and the more you're going to be able to access some of the newer tools, and that IT will release control of a lot of things, the better your product is. So I think, it's obligatory to talk a little bit about the history of where everything started, because I think, especially as we talk about some of the newer technologies here after the break, it's good to understand where everything came from. And the oldest product of Microsoft, one of the oldest products of Microsoft, is Excel, right? And everyone's familiar with Excel, and entire very large businesses are run on Excel, for better or for worse. And soon after Excel came analysis services, and analysis services has been around. It's a very mature product. I don't want to say it's like 30 years old, but it started out with this multidimensional product. This is what everybody maybe has heard in their company called cubes or OLAP. kind of become a dirty word in organizations. Frankly, people don't want to hear the word cube a lot, and that's because of some of the issues surrounding data quality, performance, UI, and UX that companies have experienced with cubes. And so these were the two products. And so if you wanted to take your Excel file and you want to take your model, whatever data you had built in Excel, and you wanted to share it with the company, there was not an easy way to do that. And at least not an easy way to certainly make it an enterprise quality type solution. And that's what analysis services did. It allowed you to take a company data model and allow people to then use Excel to look at that model and drag and drop and slice and dice that data and filter it as they saw fit. And soon after that, the same team that built analysis services, which was the SQL Server team, built Power Pivot, which was an add-in to Excel. And Power Pivot uses the same engine behind the scenes as analysis services, Tabular. And it allows you to basically take data from Excel or from any other data source and compress it into memory, sometimes up to 50% compression. And then you can build measures and calculations on top of that and basically have a cube inside of your Excel file. And that was very similar to what people were doing manually in Excel as a VLOOKUP. You would have tabs and tabs and tabs and tabs full of data, and you would bring that data together or create relationships between those tables or those tabs with the VLOOKUP function. And Power Pivot was like VLOOKUPs on steroids, essentially. And then, of course, people wanted to share that in the same way that analysis services was being shared so easily, and that, of course, was SharePoint. And whether that was an abysmal failure, I don't know the perfect answer to that, but it wasn't the best solution possible. And around that same time, Microsoft itself started to change, and they started to become a little bit more startup-minded, and they started to crank out products pretty quickly. The Power View product, Power Map, if you remember any of these things, these became tabs in Excel. They weren't perfect, but that was the first inkling of Power BI-like interfaces, and it was very different than the early days of Excel. And there was also this thing called Data Explorer. Data Explorer became what we now know as Power Query. When you want to get data in Power BI, that is Power Query. And it allows you to write an entirely new language. If you had a lot of coffee in the morning, you can write this language called M, and it allows you to transform your data on the way in to your model. And so it basically gave business users the ability to do extract, transform, and load, or ETL operations that were normally relegated to IT departments. And so the key thing to remember is that behind these two things were two key applications that were built at Microsoft, the VertiPaq engine and the mashup engine. And you can actually see these two things running in Power BI. If you were to look at your process viewer in Windows, you'll see that the mashup engine is the thing that's running M code and transforming your data and pulling data from data sources and dumping it into the VertiPaq engine, which is squeezing that data into your memory on your laptop or desktop so that you can run lightning fast visuals in Power BI. And soon after that, actually, the VertiPaq engine, of course, not soon after that, actually, the VertiPaq engine started with the Tabular product. And so the Tabular analysis of Tabular is the same engine that is in the Power Pivot model. And indeed, it is the same engine that is also running in Power BI. So Power BI kind of became the perfect solution, of taking data from any source and building relationships between it, something Excel users have wanted to do for forever, and then actually also building a very nice sharing platform on top of that, where you can actually publish your visuals and share it with the rest of the organization. And they're starting to take that even further, where I can actually classify data as sensitive, or I can certify data sets and actually see the lineage of data throughout my organization. All of that is now in the Power BI service. And eventually, Tabular also got the mashup engine, so you can run M just like you would in Excel or Power BI. You can do that in the IT department, or that central BI team can use Visual Studio and use M code in the same way. Recently, Microsoft has created Power BI data flows. And so this is, again, starting to encroach is probably the wrong word, but starting to wade into the central BI team level of tooling. And so data flows is a way for business users to not only simply run M code, but run it at scale and run it as a workflow, and even refresh this incrementally like a central BI team would do. And this is now all kind of come together in what Microsoft's calling the Power Platform, and that includes Power Apps, Power Automate, and Power BI. And so what Microsoft's trying to do is not trying to make IT go away. What they're trying to do is expand IT's bandwidth. I think everyone has experienced the lead times associated with BI teams or central BI teams producing cube analytics, cube-based analytics, or any kind of analytics. It's just hard, especially in larger organizations. That team is typically much, much smaller than the 5 to 10 other departments that are clamoring for data. And so Microsoft is trying to democratize some of this capability to the business, at the same time trying to provide the governing tools necessary so that it doesn't turn into a sprawl of data. So we'll talk about that a little bit after the break. So you may have been thinking, why use Power BI? Or it sounds like analysis services isn't the end all be all anymore, now that the Power BI service can host similar things. And you're not wrong. Amir Netz on the Power BI team, this is a recent slide from earlier this year about how they do want to build a unified BI platform, something that is centered on self-service, centered on data lake, and centered on AI. And that vision does not necessarily include analysis services. Analysis services is not going anywhere, I assure you, but they do refer to analysis services as an external model, internal model being the Power BI service itself. And they are rapidly moving features out of analysis services and into the Power BI service. So it's important to know that, all else being equal, Power BI is going to have a parity of features with analysis services. And again, the whole point of that is so that you don't have this external model. You don't have this thing sitting out there that's so important to your organization, this model that's so important to your organization, sitting out there and unavailable to be changed by business users who are the bulk of the users in the organization. And Microsoft has heard that over and over and over again. And I think this is them trying to actually come to terms with that bottleneck that everyone has typically experienced. And so again, we'll talk about that shortly. So in review, everyone's familiar, if you're on this call, probably you've used Power BI Desktop, and that's a free thing you can download from the Microsoft Store. And it provides a data model that has tables with relationships between it. It allows you to use Power Query Desktop when you say, get data, and you start, adding transforms, which you'll see in a little bit. That's Power Query Desktop. It lets you to connect to sources and pull data in. Then, of course, you have data sources itself that you can pull in through Power Query. And then Power BI Desktop also allows you to build visuals on top, which are kind of the key thing that you want users to adopt. Now, analysis services is the older, more mature application that is meant to live on a server, and which is one of the reasons why it's typically centered on with IT folks. And it provides, as you can see, 3 of the 4 items here. Can't have visuals and analysis services. You need a front-end tool for that, which is typically Power BI Desktop or Power BI. The service is this web-based thing. This is where you publish anything you build in your desktop. Power BI Desktop gets published to the service, and it provides a slightly different nomenclature to the same stuff, which is the model that you made in Power BI Desktop becomes a data set in Power BI Service. And if you do any transformations data online with things like data flows, that's now using what's called Power Query Online, and which is, again, you should have pretty much the same features between Power Query Desktop and online, but there are differences. And data flows are a way for you to take data sources and actually apply transformations to them at scale and allow you to create kind of repeatable patterns, something that's not just doesn't only exist inside your Power BI Desktop file, for example. This is a lot, Power BI Service is all about sharing your solutions. And finally, you can create and edit visuals inside the Power BI service. Finally, here's this Power Platform thing we keep talking about, which includes Power BI. And it has tables are called entities in Power Platform, right? And these are typically stored in a data lake or in what they call the common data service. And this is just, basically you can think of it as tables in the cloud are entities. And Power Query Online, again, is the choice for the platform of transforming data. Same experience, same M language, it's just hosted in the cloud and can be parallelized and that sort of thing. Also, now they've got this kind of additional thing. They have data flows too, but they also have this thing called flows, and that used to be called Microsoft Flows, and now I think it's called Power Automate. But it still retains that name, flow.microsoft.com, when you go to it, and we'll look at those here shortly. And so the difference between data flows and flows is flows are more about orchestrating things, saying, hey, when it's 5 o'clock, do this thing. Hey, every time this happens, every time I get an email, do this other thing. It's about, if you're familiar with that open source version, if this then that, or IFTT, that folks use kind of to automate their life. This is the same kind of idea. It's just for orchestrating. It's not necessarily for moving data around, although it can kick off data operations. Data flows are from moving data around, actually processing data and moving it from A to B through a set of transforms. So that's kind of the difference there. Any questions about these tools? I don't see any in the chat, but again, feel free to post them in the chat. Sammy will either answer them immediately, or I'll kind of, again, keep posting or taking a look at the chat to see if there's any pop up. There we go. All right. So when should you use these things, and how do they interact with each other? At the very basic level, you have the Power BI desktop tool, and you can go out and grab data sources with that tool, whether it be Salesforce or be a SQL database in your company, or be a flat file on your computer with, full of marketing data. That's the purpose of this desktop tool. And what you produce when you make all those relationships between it, that becomes your semantic model. It's not exactly like whatever it is you're pulling from. Hopefully not, table for table. You want to kind of do something a little bit higher level. If I'm going to pull 5 tables from Salesforce, I may choose to kind of join them together, make them a little bit simpler, change the names, and that becomes like a semantic or virtual model on top of all of that chaos. And then I can publish that model to the Power BI service, and then it changes its name to a data set. And this is something that other people can access and reuse, or that's you sharing that data set with the rest of your organization. And again, this is where you see analysis services, which also is a semantic model, but Microsoft refers to this in documentation as an externally hosted model, right? And that's not derogatory. It's just important to know that it is the same thing as Power BI. In fact, the same engine, but it is hosted elsewhere. And there are very good reasons to do that. For example, to get all the full features of Power BI, it's expensive. And a lot of people have analysis services, since it's possibly a 30-year-old product. They probably have analysis services servers paid for and sitting around on premises. And those can continue to be used and updated. And you can host a lot of models on that server without incurring a typical cloud cost of every second being billed, right? Now, that may not be the case, and to tell you the truth, that sounds like it's not a lot of money because you've already paid for the server, but in fact, there's a lot of total cost of ownership around that in terms of the people who have to manage it, in terms of the licensing to allow you to update it, and it goes on and on and on. And so I think when you do a true comparison, a lot of folks decide that the Power BI service, especially with its capabilities to extend a lot of this data transformation and pipelining work out to the business, is really, really important in order to expand the pipe, to remove that bottleneck in the IT department. Finally, there's this other thing called streaming. Everyone talks about streaming data these days, and that's not something that you pull into the semantic model really in either case. Streaming is its own beast, and it has its own set of tooling, both in Azure and elsewhere. And so I'm not saying that you can't pull data in every minute if you wanted to into analysis services. It may not be recommended. Really, when you start getting down to that 1 minute or less type speed, that's a streaming type of use case, and there are dedicated data sets for that in the Power BI service. So they kind of come in from the side. And then finally, you build your visuals. So the new tools, the data sources like Salesforce and SAP is what we're talking about here. And so if you want to combine these two things together, you can either use Power BI Desktop, but again, that's not necessarily a very repeatable way to do things. Once you publish that, it's really on you to continue updating that combination of data between Salesforce and SAP. If you really want to allow other folks to contribute or certify your data flows to make sure the data quality is high, that's when you start using things like Power BI data flows. This allows you to go to the same data sources, but create a cloud-based workflow of pulling and transforming data that you can get other people's eyes on it. You can put it through a deployment process, and also you can dump that data to Azure Data Lake, which is what they're calling the common data model in the Power Platform. And this is a common way to talk about things like invoices or customers or leads or accounts. This is a standardized place that not only Power BI can talk to and understand, but tools like SAP and Microsoft Dynamics understand the common data model and can interact with it directly without you writing any code. And that's part of Microsoft's Open Data Initiative, where companies have come together and said, hey, look, if you have a really expensive thing like SAP, but you also have a bunch of other things, we know how to talk to this central model so that you don't have to go write this yourself, in a SQL database somewhere. And so it improves the quality of your overall kind of data hub in your organization. So you can dump the data in a data flow in a standardized way into the common data model and then access that from Power BI. And we'll talk about a really key piece of this, which is live connections and how to avoid live connections and some of the pitfalls of that in just a minute. Finally, there's the Power Platform data flows. Power Platform, again, Power BI is part of the Power Platform, so this is a little confusing. The difference is that, well, there's several differences, but the key ones that matter is the Power Platform data flows were born out of big ERP systems, okay? They were born out of things like Microsoft Dynamics or SAP, and it was born out of the Open Data Initiative. So it's really centered on this common data model concept, and it's really centered on this thing called the Common Data Service, something that the Power BI data flows can't touch at the moment. And so when you want to pull data in and out of SAP, like a hub, or like what people might call an operational data store in the past, Power Platform data flows are the way to do that. It's much closer to Azure than it is to Power BI. In fact, if you look at their release plan for next year, they want you to be able to promote Power Platform data flows to Azure Logic Apps. And I know I'm flooding you with all kinds of words, but Azure Logic Apps are what the central BI team or your infrastructure team would use in Azure to actually do the same kind of automations that you would do in Power Automate or what used to be Microsoft Flows. All right, it's an enterprise scale tool, Logic Apps. And so what they want you to do is build kind of orchestration and data flows inside the Power Platform and then be able to promote that to your more enterprise central team so that they can take on the production management of that. They can take on, dealing with late calls at night when something goes wrong. They can integrate it with the much larger system of the SAPs and Salesforces in your giant organization. And that gives you a flow for that. Power BI data flows don't, at least that I see on the map, have a way for you to do that. And so there's nothing on the roadmap to take a Power BI data flow and bring it up to the enterprise level necessarily. So Power BI data flows, instead, you can keep your data in the Power BI service itself, or you can store it in the data lake. And so it's just much more focused on the Power BI service And the scalability of it is a little bit greater than that of the Power Platform, because I can do a lot of parallelization with Power BI Premium. I can reserve a capacity for that. And its performance is really dedicated to analytical style work use cases. So I hope that makes it a little bit clearer on which of these two. We're actually going to look at both of these after the break. Any questions about these tools? Again, feel free to drop them in the chat now. I don't see any right now, but I'll come back if any pop up. All right, so let's jump right into it. So Power BI Desktop, there are typically 4 phases in building a solid model, right? You need to go out and get the data, of course, and that takes some thought, right? Now you're talking about Power Query, you're writing M possibly, if you're super advanced, and that Power Query M, or that M language, is getting translated hopefully into queries that get sent against your database. So if you're trying to query a Dynamics database or trying to query some source system, even like Salesforce, M is going to translate into some sort of query that goes out and gets that data. And you got to think about the performance of that and whether you're getting the right data. Again, focus on data quality first. And once it's in Power BI Desktop, that becomes a set of tables that I need to start building relationships in. Again, Power BI, and what we'll see in a minute, will try to infer those relationships between the tables, and it doesn't always do a good job. And what we see a lot in clients is they'll either have left what Power BI did all by default, or maybe made it slightly worse. And I think they typically come with problems that say, look, this thing is just not working like I want it to. And we help them typically get back to the basics and think about this data model. Because I think it's really easy in Power BI to fall into the rabbit hole of just trying to solve the problem to get it to work so that I can get it back out to the business. And that is a vicious cycle, of course, of, you typically end up with a model, again, that is not making your life good, right? It requires a lot of maintenance. And sometimes you have to go back to the basics and rethink exactly what it is this model is trying to do. And so we'll talk kind of through that in a second. And then we want to enhance that model with measures and some of the advanced capabilities of DAX or calculated columns in order to kind of produce the report that we want the business to see. And then finally, that we take all those relationships, all those tables, all the measures we built, and we actually produce our visuals. And I see the arrows are going from left to right, but honestly, a lot of times you have to think about the visual first. There are an enormous amount of visuals in Power BI, and sometimes those visuals have a very strict requirements about what the table should be. Sankey is a perfect example. If you go out and Google Power BI Sankey, S-A-N-K-E-Y, that's going to be a really specific type of table you have to build. And so the way you transform data to get it into that format so that that visual will actually work, sometimes you have to start with the visual first and think about how I want to present this information, and then what the data model is required to present that information, and then you go out and get the data. So some of this, it goes both ways, unfortunately. All right, so I see a question about Power Automate. Does it work any different compared to Flow? Well, so Microsoft Flow was rebranded to Power Automate, my understanding. And so it should work the same. And as far as I could see, it's pretty much the same. Again, the goal is to, just like it says, automate things, not necessarily move data but from step to step, right? It's kind of an asynchronous thing. I might want to kick off this, or I see an email, okay, do this, rather than, okay, I'm going to join this table together, and then I'm going to add a column, and then I'm going to join another table to it. That's kind of a data flow, and that's where the data flows come in versus automate. So I want to walk through some of the best practices of building a model. And one of the things we see often is, and frankly, we see this in BI teams with Visual Studio and Tabular as much as we see it in Power BI, so it is common, is that many models that we see look exactly like the data source they came from. That is, if it took 15 tables to get the answers I need, my model typically would show up with 15 tables in it. And it's difficult to scale something like that, right? And some examples are like invoice header versus invoice detail, or leads and customers. Like these tables can typically be combined in some way so that you're dealing with less relationships and less tables. The goal in Power BI is always to have the least amount of relationships possible and the smallest memory footprint possible. So you don't want to have a lot of columns hanging around that you don't use. That increases the memory footprint, which means Power BI has to scan that data, a lot more data than it usually does. And then lots of relationships mean lots of what they call dictionaries in memory. So again, a lot more memory space is used up to deal with all those relationships. And again, Power BI has to traverse a lot more relationships. So performance is simply worse, all else being equal, the more relationships and tables that you have. Now, knowing those two principles, you may think that having a single table is then a good idea, but that would be too far. And a lot of times, this is almost even more inefficient than having too many relationships. And that's simply because Power BI has to sift through a very wide table rather than lots of tables that are kind of organized for it to be more efficient in terms of optimizing whatever query that you're asking it to produce. And so we don't want to go as far as building one flat table, and we don't want to have tons of tables that match exactly the database. We want to do something in between. And so that's what these next few slides are, is like, what is that in between? So in terms of, if you were to think about what your BI team does internally, they really split the world into two things. Everything's either a dimension or a business entity, or it's a process or a fact table. So an entity is any kind of object that actually interacts in your business. It is typically, like a customer is a perfect example. This is an entity that you want to track metrics about. It could be an account, it could be vehicles, it could be facilities, it could be oil rigs. I mean, those are all entities, things that produce data, and things that take actions in your business environment. Those are your entities or your dimensions. Your business process is anything that those entities are doing on a regular basis, or what you're doing to those entities. And so in this case, page views. Your customers are coming to your website and kicking off page views every time they view or click through to load a shopping cart or to look through your brochure site. That's a business process that you want to track. And the relationship is just like it sounds. How does a customer relate to page views? Well, a customer can have many page views. They can come to my site she can come to my site many times, but a given visit to the site is made by one and only one customer in this case. So again, the IT team or BI teams will typically call these dimensions or facts. And it's really important that every fact table that you make is tracking a specific business process. And if you hold to that principle, you may find that there are cases where a single table you pull from a source system should actually be split out into two fact tables, not kept as one. For example, a lot of times in Salesforce, you have really, really deep tables of data that have a column in there for categories, different styles of process, different types of appointments you might have. And that's a good case that, like, you don't want to track all those in one place because they're two different metrics related to it, so you'll split them out into separate fact tables. So all I'm saying is that make sure that whatever fact table you build, you have a reason for building it, and you're trying to track a very specific process. Because fact tables are typically the source of a lot of performance issues. And so you want to make sure that whatever fact tables you add have a purpose. Finally, the dimension is where you want to roll up data. This is where your slicing comes from. You want to see page views by something, page views by customer, page views by gender, page views by zip code, right? Those are your roll-ups on the dimension side. And then all the numbers, anything you want to add up or average, those all start in the fact table. Now, these are guidelines. As far as Power BI is concerned, a given table in that model can serve both roles, which makes it a little more complicated. So you could technically have measures on dimensions. And does that make it a fact table? I don't think so. It's about what the primary purpose of a table is. And so just keeping this in mind, that this is the standard, and kind of deviating from this is inviting, lower performance or more headaches. And so this is what your BI team does, is to the best of their ability to make their models as fast as possible. And this is what Microsoft and other Power BI professionals will do to make their models as fast as possible. Okay, so when we talk about, hey, we don't want a one flat table, and we don't want tons of tables and relationships, what is this thing in between? The thing in between is a star schema. And it's called a star because the yellow table in the middle and the points and the blue items are the points make it a star. And the star, at the center of a star, of every star, is a fact table, a table that is definitively a fact table. In this case, page views. And the dimensions around it are the way in which we want to roll up page views. We want to know maybe what actual page they were on, what campaign brought them to that page, what age groups are looking at the site, and then of course page views by the calendar or by date. And as you can see, the star indicates a many relationship, a many to one, and this is what we typically find sometimes, is that these relationships are reversed, and people either get bad performance or they get strange numbers when these relationships are reversed. So it's important to remember that the fact table is almost always on the many side relationship, and dimensions are almost always on the one side of the relationship. If you add an additional table, not from the fact table, but out from the dimension, that's called a snowflake. And if you go online and Google this concept, you'll find a lot of different opinions of whether this is a good idea or a bad idea. I would say that, if the table sizes are small, it just simply doesn't matter. Now, it's always whether the tables are small and whether you expect them to stay small. So you want to always think about not only whether are they small now, but if in a week, if I'm loading machine data, they're going to quadruple in size in a week, possibly. But if it's simply, a lookup table that has, like this is, a small number of companies that your business interacts with, a snowflake of that size really doesn't matter. The purpose of doing this is for you to be able to manage this table separately from the other dimension that it attaches to. So typically, I could join company and customer together and keep them as one table, no big deal. The primary reason to keep company out is because I want to manage it differently. The last thing is hierarchies you make in Power BI. This allows people to quickly double-click a visual and drill in, and you have to manually create hierarchies. Typically, dates are an exception to that, where Power BI will dynamically create these hierarchies for you. So now we're starting to get into what the real value of a model is, and that is, the value is that you can drill across multiple stars. So having just one star is clearly valuable, but the ability to see page views and how page views may translate into actual dollars in an invoice, now we have a power we didn't have before. Whether you try to pull this data into Excel, 20 years ago and get this answer out, this model by far beats that, because you can drill across. That is, I can see invoices and page views by customer, and I can start to analyze how money either arrived at the company or people who came in and saw the page and chose not to create an invoice, right? And so now I'm really able to see multiple business processes in one place. It's called drilling across. And I think the biggest pitfall we see on clients is a tendency to connect the two yellow tables together. At all costs, you want to avoid connecting fact tables together, because typically they're the biggest tables in your model. And connecting them together, it'll feel intuitive, but I guarantee that over a few months, as you add measures to it, you're going to regret having done that. There really is no situation where connecting the fact tables together is better than connecting fact tables through dimensions. The only one that I can typically think of is if you really want to see a low-level data. That is, say you had invoices and contracts, invoices born out of contracts, of course, and you connect them together, I can actually nest those two things underneath each other and see a really low level, hey, this contract showed 5 invoices. But again, the more you want to see low-level data, the more Power BI is kind of the wrong answer for that. Power BI does have paginated reporting, and there's also SQL Server reporting services. These tools allow you to, instead of high-level analytical style queries, let you see that low-level data in a much more performant way. If you constantly ask an in-memory model for the lowest level data, then you are defeating the purpose of that in-memory model, because it doesn't have, its power is the ability to aggregate data. And so it's a long-winded way of saying is try to avoid connecting fact tables together. So in summary, tables, relationships, there's a few different types of relationships, one-to-many, one-to-one, and many-to-many. And there's lots of literature out there on those 3 different types. One-to-many is the most common. I would say, one-to-one is extremely rare and typically means the 2 tables could be 1 table. And many-to-many should be rare because there is a performance impact to that, but sometimes it's unavoidable. So really, your model should be comprised almost entirely of one-to-many relationships, unless you have a good reason to do the others. And also, these relationships, you can notice that the filter direction goes in the direction of the arrow. So in the case of the product dimension here, in the sales fact table, every time I set a filter on something in that product table, it automatically filters everything in the sales table. And that's why I can write really simple DAX measures like sum units. I don't have to give Power BI any more information than that. It understands, because of these relationships, that every time I pull in products or dates or campaigns, it knows to adjust that measure accordingly based on context. So kind of in review here, before we kind of open up Power BI and take a look at this example, when we pull data sources in, it has to go through the query editor, whether you're using it online with data flows or whether you're using it in the Power BI desktop tool. You're using the query editor to transform your data and essentially create a series of queries against data sources. And you then move through the different buttons on the left-hand side of Power BI. You'll start typically with the relationships or the tables. They'll show up at the very bottom, and you'll move on to maybe modifying some of the data properties or adding calculated columns, and then you'll create your reports and kind of go back and forth that way. That's kind of the flow of iteration there. And when you look at that bar on the left-hand side in Power BI, and this is important if you kind of come into a position where you've got 5 or 10 Power BI files and you're not sure how to make sense of them or where they came from, you see this live connect. Those you won't have an option to look at the data or look at the model for a live connection. And that means that model is connecting either to analysis services or it's connecting to another data set in Power BI service, which is essentially analysis services. And that means that because you have a live connection, I can't mash it up with any other data. And that's going to become important after the break when we go look at Power Automate and Power Platform data flows and Power BI data flows. That to avoid this problem, we hear this constantly from customers, like, how do I do something better than shared data sets? If you've experienced this problem before, that is, you can have a person, an analyst in your company, who produces a really nice Power BI model and they publish that to the Power BI service. And yes, they can share that data set with others, but say you go use their data set, say you pull it in, and what you end up with is a Power BI desktop experience where you only have this one button, like it shows here. I can't go grab my marketing list and add it to that. I can't go I grab my industry or prospects file of data and mash it up with that. I have to go back to the person, or at worst, the BI team, or not at worst. If I want to wait a little bit longer, I go to the BI team and I ask them to modify that model to add my custom data into it. And so that's the biggest downside with Live Connect, and that's the biggest reason to use things like data flows and the Power Platform. And we'll dive into those after the break. The next thing you might see is the report icon and the model icon. That indicates that it's a direct query data source. Direct query says, okay, look, I'm not going to hold any data in this model. That when I hit refresh, no data comes into the model. Instead, every time I interact with the model, Power BI is going to produce a query that works with the source system. And there's only a short list, well, I guess there's a longer list now of source systems that will work with this, but it's going to produce a query on the fly. And this is great when you have lots of data to look at and you need to look at that data in real time. That is, as soon as if I'm using an accounting system, and an accountant, when they want to put a journal entry into that system, they typically want to see that journal entry show up right away. They don't want to wait to the midday cube processing, right? They want to see it right away. And that may be a good case for direct query because they can, every time they move the visual around, that journal entry will show up immediately because it's sending a query out to that source system right away. The biggest downside with direct query is that you lose an enormous amount of features. It's too long of a list to kind of go through, but if you look up direct query limits on Microsoft Docs, it'll hit you right in the face. That like, oh, okay, if I use direct query, I can't do these 10 other things. And so Microsoft always recommends to do an import model wherever possible. And again, if you want real-time data, that's what streaming data sets are for. And we'll touch on that just briefly. We won't build streaming data sets here, but if you want stuff in real time, there are tools for that. It's outside the scope of all three of the things you see on the slide here today. It's a separate thing. And then finally, what Microsoft recommends, and we would recommend, every time, unless you have a really good reason, is to just always import your data into Power BI. And that's when you get all three buttons, and I can mash data up with whatever I want. And if I use Power Automate, or the Power Platform or Power BI data flows, this is the experience that I get.